ఇది పెట్టు టేబుల్ పెట్టు
Friends, myself Udakumar. I am doing PhD under the guidance of Professor Vair. Now I am going to discuss about the demo of the 3D printing process. Right now you can see this is the LPBF process, which is used to call laser powder bed fusion. I think you might have heard about laser bed fusion, right? Like, what is your suggestion, like your point of view, how it is going process? Like basic principle, I'm asking you. Like,
with the help of laser, the powder will get fused and solid.
Yeah, that's a basic principle. Okay, here there are two pistons are there. One we used to call supply piston, another one sintered piston. Okay, so sintered piston it is used to melt the powder, and with the help of the roller it will spread the powder. Okay, right now I'm showing the how it will going to melt here with the help of the laser power. Okay, actually there are four parameters of them mainly. One, I heard about energy density, right? Energy density.
Yes.
Like what?
Energy density basically it's a power per unit volume, with P divided by your laser scan speed multiplied by thickness multiplied by height. Yeah.
So those are parameters. Right now we can't change layer thickness here and laser power. And we can change the laser power can change here. Layer thickness you can't change because right now we are following only on 30 micron size only. 30 micron layer thickness. And followed by hatch thickness you can change. And hatch spacing also. I think like around 70 to 75 micron like that. So here in this machine we can make four materials, mainly four materials like aluminium, titanium, cobalt chromium, followed by stainless steel. Okay, right now we are printing stainless steel like 74 pH grade, precipitation hardening steel. Okay, using these parameters we can print like mainly using for intricate shapes, not basic shapes like kind of rectangular blocks, cylindrical blocks. Right now we are printing like lattice structures. I think like previous session Srikanth might told you about the lattice structures. So with the help of EM technology only you can print those structures. Okay, right. So four parameters I told you, right? Energy density, layer thickness, followed by laser power and hatch spacing. I think in 3D export we can change the like hatch spacing and hatch pattern. So there are different patterns are there. Like what are those? Like rectangle pattern, like chessboard pattern, like rectangle stripes, followed by hexagon in and out. So we are following hexagon in and out strategy. Why? Because it will take more space and more time to get the like more precise part. Okay. And this is the basic user interface. Right now you can see this is a project which is consistent of like what are the parts used to like print. So observe. So So right now I am printing tensile samples using lattice structures, engaged gun, followed by cylindrical coupons. Those are also lattice structures. And this is a printing process, like over interface. Like each time the layer will spread, every layer, and laser is going to interact with the powder particles. It is going to fusion, like melting, proper melt. Only powder will melt. And followed by again the roller will spread the next layer. Same like this, stacking of the 2D layers.
Yes.
We can finally get the 3D component. Okay. See, this is every visualization, means every layer, how it's going to give like a print. You can observe. See. So these are the tensile samples, followed by cylindrical components using lattice structures. These are porous structures. Okay. And after that we have to do post processing. Like what are those post processing techniques? Any idea? Without going to short pinning, like I need to.
First you have to remove the part, no? Wire radium will do.
Yeah, wire radium. First wire radium you have to do. Okay, followed by if you want to increase surface like roughness or surface improvement, you can do sandblasting kind of thing. Right now we are having wire radium followed by sandblasting. And for basically for lattice structures, some powder particles will going to insert here. You can't able to move. You can't able to remove also. Right now we are like following that ultrasonic gator. Means vibrator kind of thing only. We have to keep the beaker in between the we have to place the lattice structures in the beaker. We have to steer it.
Yeah.
Then some powder particles will go outside. Obviously some particles will go inside, like with the attachment of the surface. Those we can't able to remove. Why? Because it is indicated shape right in that lattice structures. You can't change that shape. So we can't change this to the shape mostly. So that will be like we have to do either heat treatment also for like heat treatment process, like kind of to improve the mechanical properties. Okay. And followed by this is the laser interface. Laser power will be like fiber and laser will be there, which is usually going to melt the that specified area. Yeah. One by one, like come and see the like basic process. Like one by one. Mainly the powder will spread the substrate using the roller. So you can observe in the machine right now.
And the specimen is arranged as you told that it will be at some degree.
Yeah, we need to follow that.
Yeah.
Those guidelines we need to follow in setting. Yeah. Otherwise, your pressure will be more if you.
Yes.
So if it is small parts, it won't be much. But if you have a bigger parts, so the contact area, the contact surface,
Yes, sir.
it should be as minimum as possible. Then you can organize that.
Yeah, thank you. We have an already printed copy.
Printed samples.
Take after.
So while evaluating the surface hardness of it or roughness of it, so we test it after doing sandblasting or before sandblasting only we do that roughness.
So, yeah, it can be done as built.
As built also.
As built also. Yeah. As built. If you are not satisfied, then you go with the
After sandblasting.
Yes. So normally we'll get a very good finish, maybe around 15, 10 might area value. Yeah.
That's nice.
So is there a possibility to change the upskin parameters so that we do
Which kind of parameter you want to
upskin parameters? Upskin and downskin parameters.
Upskin, downspin, that is only design part. Huh?
No, actually upskin, downskin parameters so that we can achieve a better surface roughness.
Yeah, that can be done.
We can change that.
Yeah, we can change that. Yeah, we can change that.
So sir, while loading, we are loading it from the front material?
Yeah, from this. Yeah, this one. Anyway, right now it is. Yes, we cannot open it. Sir, we will be loading from here. Okay, so our loading will also there. So, put it in.
Kelvin conditions chapel study.
Okay. In between, you have to load the board, right? Actually, there are two blow boards are there here. So, with the help of the blow boards, they have to load the powder.
Yeah.
So, using because we can't open the door. Why? Because in initial igniting atmosphere will be there. If you change the igniting atmosphere, obviously it is going to affect the printed part. So that's why they are giving two doors. With the help of some snake door will be there. Thereby, how to keep the powder, metal powder inside.
So normally it will be first we need to do it in the ovens.
Yes.
But
Yeah.
to remove the moisture. Actually.
Yeah, moisture removal. Yeah, then we'll do that one, and then it will be.
And how do you decide the flooding? That you must be doing flooding of the gas no before starting the print.
Yes, inner thing.
Yeah.
Inner thing. Yeah, we have done in the morning that one. we
Okay,
started.
that's
Morning
what
after
we-
I think I will show you after.
There, how much pressure you make in the?
Actually, 6 bar we are making pressure. 6 bar pressure.
Okay.
Yeah.
I think they are the same. SLM.
Same, sir. 6 bar
6 bar pressure only.
6 bar.
are
6 bar.
Standard.
Yes, sir.
And for two materials like aluminum and titanium, we have to follow like argon atmosphere.
Yeah.
So I have to use argon gas.
So right now it is a nitrogen gas.
Nitrogen.
So
Because-
for the non-reactive it is nitrogen, like you said, steel, cobalt, chrome.
Okay.
Except aluminum, titanium, we'll use nitrogen gas.
So this machine also comes with nitrogen generator, sir?
Actually, it is a starting model. We don't have a generator, so we are using cylinders.
Cylinders.
So we'll be changing.
Okay.
Yeah, we'll be switching nitrogen to argon, argon to nitrogen.
This is the final part. Okay. So we are going to use lattice structures. I told you, right? But here we are using some like supports.
Yes.
Actually, some lattice structures are there, PPMS physically. There you can use, you can print without supports also because it will act as self-supporting nature. So this is the final part, like after white bed. You can show one by one.
You can do that. Okay. Wire cut, huh? Workshop.
Sandblasting.
So I'm not like
Is it aspirin?
Aspirin. After
Yeah, as-built. As-built only. That's what we didn't remove the substrate also. No, it's as-built. Yeah, we didn't even do any furnace. It's as-built only.
and here we have to remove support structures. So thereby white cut will have a lot of like trouble also because communication structures, right?
This is a medical implant. Tomorrow I am going to explain one of the case.
Yeah.
Yeah, finish is very nice. Yeah. This has been. Yeah, finish means is very good.
So are these
Near
optimized
net.
process parameters that they
Near
use
net
or
only.
they use like
Then you need to do subtractive
Yes,
manufacturing
yes.
on it.
optimization for
Hybrid only then.
Hybrid
Again,
only.
Yes, sir.
always
Initially we
need
get
to go with it.
track
We
like
are going to get only near net shape, but
But
not.
I think the resistance guys will give some different performance. Right now we are calling
Yeah, we have an oil.
For titanium,
We don't have transfer adds one more.
because for getting high resistance time after post process.
Yes, yes.
So this is the final part without doing any post processing. Just wire cut.
Has built. Yeah, we have removed with the wire cut from the substrate. We have has
So
built.
this much complex we can't be able to make it using the conventional manufacturing. Using helium only you can able to print here. That way LPBF have high like advantage compared to like previous problem process.
So what is the substrate material? Same something for
Yeah, same. Here we are using same materials, same substrates.
Steel,
Because
steel,
that-
aluminum, titanium, titanium.
What basically materials?
Steel.
Is steel, right?
Yeah.
316.
Yeah.
Titanium. Plates. Plates. Okay. Continue with it.
Yeah. After we have to grind substrate.
So is there a possibility to use, say, 306N or any other stainless steel material?
Yeah, we can do it, but we need to develop the parameters.
Yeah, that's what I'm asking. So,
Yes, there is a provision, but these people are very tricky, you know. They sell, commercial people, they sell they will be charging for that.
Okay.
But it is possible. But otherwise also, we can try as a research purpose. And one more thread is, so if it is under warranty,
Yeah,
they may
that-
say that warranty will
directly
void.
say that warranty will
Yes.
So that's why I asked, sir. So basically 316N,
can you show in a 3D expert maybe some parameters like maybe? Yeah,
Actually,
Fabrication. The same thing we tried. More or less like trial and error, or we conduct, but like they may be having cleverly, they will be selling. So means they have configured this machine with the 4 materials when we purchased.
They have already optimized.
Yes, they'll optimize that and they supplied that set of parameters. But if you see in the 3D expert, we have plenty of materials. Yeah, we can try. But as I said, like warranty.
Warranty
that
is-
is another issue.
They will not renew the AMC also.
AMC, then it won't cover under AMC. Those
Only
things.
we have to purchase the material from the
Yeah, but nowadays it's okay. We tried outside material.
Okay, sir.
It's working. It's working. But if something goes wrong, then they may say that you use some other material like that.
That is fair.
But right now we tried with MIM. Indo-MM we tried, and Matrix Nano also.
Matrix Nano.
Both are made in India. Made in India, make in India powders. It's doing good.
Indonesia is made in India, so it is exported from Poland, I guess. Poland or Belgium.
Yeah, maybe that. Yeah, it's injection, metal injection also. But I think they're claiming that it's a made in India. I don't know. Maybe they might have started
I have
here.
also
I'm not
heard-
sure.
I have also heard this.
Probably.
Made in India.
Probably it was, for many years I actually worked on high carbon steel.
Okay.
So probably they imported that material
Right.
specifically, or maybe they produce a few of.
Right.
So what is the base plate heating parameters that is available?
Preheating
Base plate-
parameters.
Build plate heating.
Regarding substrate.
You
Yeah.
have a provision for this?
No.
No, we are not preheating. You are asking about preheating the.
No, sir. Build plate temperature.
Build
It
plate
will be
temperature.
maintained at some temperature
Like
in
in
US.
machine, after going to start, going to preheating. Around 80 degrees.
Automatically
for,
that will be done, sir.
Yeah, automatically.
So preheating is automatically by the machine.
No, actually in EOS cases it will be directly maintained at 200 or
Yeah.
maybe it will. Yeah, depends.
That
Vary
depends upon
from.
the machine and machine.
Yeah, that's what I'm asking. Is there any provision?
No.
No.
Right now. Right, next question.
Okay. So do you have any other questions?
Any queries? Answer. Yes.
This was the one.
నేనే పెట్టినా సార్ విత్ సైజ్
Okay, I think you might heard about the LPBF, right? What is like LPBF? Laser powder purification. Yeah, okay. This is the machine which is sponsored by JDL Systems, DME Flex 100, like direct metal return material, Flex 100. 100 means build volume. 100 to 100 to 80. And we are using 100 watts laser power. So before going to that, we have to do some pre-processing. Like what is that thing pre-processing means? First of all, we have to load the powder. Before going to load the powder, okay, we have to do first sieving, because the powder particles having 45 micron size, basic one. But the supplier will spend like will give more like more size. So in order to reduce that part, we have to do first sieving, followed by preheat the powder. Why? Because we have to reduce the moisture content before going to load the inside the machine. So right now we have that sieve and followed by.
Always we are using metals. So oxidation is a major concern. So that's what we need to. And not only that, we need to pump the inert gas also. So we have 2 options. One is the nitrogen. Nitrogen goes with all non-reactive materials like steel, other than aluminum, titanium. So titanium, aluminum, then we need to use argon. So we have 2.
Argon atmosphere, right? And we have to load the powder inside the machine. So there are 2 drop ports are there inside. So with the help of the drop ports, we have to load the powder on the supply piston. Actually inside 2 pistons are there. Supply followed by centering piston. In supply piston, we have to load the powder. Right now we are already loaded the SSX 316 means 74 pH steel. Okay. And apart from that, first of all we have to load the part, which is the fabrication file. I think in the previous session they might told you about 3 types of software. In the software we have to design the specified part and we have to send it to the system. And it will note down that like what you say, kind of codes, G code kind of thing. Then based on that codes, it will follow the centering process. It means layer by layer upon. So So by stacking about the 2D layers, we'll get the 3D component, right? So before going to 3D component, the layers have to melt the powder particles. I think you already seen some videos regarding how laser is going to melt the powder particles in between. Okay?
Before lunch,
Yeah, before lunch I already showed you that single layering sintering process. One layer spread followed by sintering process and followed by the roller will spread the powder again. Second layer.
So what is the thickness? You are controlling the thickness of the powder?
Yes sir, right now actually 45 microns will be the powder particle size, but layer thickness will be around 30 microns. So up to 30 microns you have to melt the powder.
Layer thickness is nothing but your Z movement of the build platform. Yes.
So that thickness we can vary also.
Yeah, we can vary, but right now we fixed it actually. So we can vary, but all are uniform thickness. But you cannot vary in between. So once first layer to the last layer, so always it may be either 100 micron or maybe 50 micron. It is fixed, but you have a range.
Even you have to change the powder also.
Whether you can bring curve.
Yeah,
Yes,
obviously.
yes.
Obviously.
You can bring that. Curved means then you curve in a number of layers. Yes.
Stacking of 2D layers will get 3D component. If you having some overhangs, if you use curvature, it will going to reduce the overhangs, support structures. So that's why we have to use some lattice structures. I think entomology also, he might told you about the lattice structures to reduce the some supporting structures.
This process powder itself is a supporting material. So it is
Yeah. But up to somewhat limit. If we have an overhang up 90 degrees, you can't able to print the part of the powder. I think my professor already taught you regarding the overhang.
First session, design for AM.
And followed by
Do you have any questions? Any questions so far?
laser penetration depth also fixed, that you mentioned.
Depth of penetration. Yeah, obviously like which we are targeting. Yeah, so one layer, but sometimes it may go. I can understand your question. Like say, yeah, so that's what even the professor, the expert also telling in the modeling also how simulation modeling also how we can. Yeah, obviously it may be. Sometimes it will be over melting, or maybe melting the previous layer also. Exactly, yeah.
So before that, we have to do some remelting, initial layers. Why? Because substrate will be the right substrate, same material, same substrate, right? They have to attach the substrate. That's why we are doing double remelting. Or else if we do single melting, like it will get the distorted. So yeah, in order to reduce that one, you have to do initial 5 to 10 layers double sinter will be preferable actually. We are following the same pattern here. After that, based on the some defects will be there, like rotor X error will come. Then they have to stop the machine, and there will be one advantage will be there. You can resume the print even after 2 or 3 days also. After rectifying the problem. Like suppose if we get rotor X error.
Yeah, in my design for AM class, I told you like how you can organize these. So you should not put like say your roller and the part. If you try to minimize the contact area between the roller and the workpiece, that's what you are maintaining some 45-degree angle. So we need to follow all that guidelines. So otherwise sometimes it will give you like error also. Yeah, so then we must be thorough in those design guidelines.
Defect guidelines.
But again, sir, quality powder support is there all around the material.
Okay.
Then also there to become in case of the injury.
No, actually here the support is also same material. We don't have a choice here. It's also steel. Yeah, support sometimes it will be acting as a conductor also. If you are not giving a support, what is going to happen? Where this heat will be dissipated. It won't dissipate heat. So that's what the support will acting you as a conducting medium also sometimes. So then, yeah, in that way. Otherwise, if you are not giving supports, so you have a huge heat
Kind of delamination.
Yeah, delamination will come.
Distortion, mostly.
But again, for providing the support also it is a difficult task.
So you have to remove that. Yeah, removing
Post
the
processing will
support.
get more time to remove that support.
But and we are not in a hurry to minimize or remove the supports, so it will lead to the thermal problems. But the thing is, yeah, I can understand the supports. Yeah, we need to put more effort during the post processing. Yes. So
And one solution will be like not to remove the supports, you have to give some lattice structures kind of thing, which is having high surface area to flow the heat. That's another solution.
So it is a layer by layer process. So support also at the same time their height should also increase with that component.
No, at a time you are making only one layer, na? So let it be whether it is a model or support. Say if you take a particular cross section, at that particular cross section, it is a combination of model as well as support. But it's the same material, same temperature you are operating it.
I think they might talk about the double ratings. I think like.
No, actually this getting the support now because it's a layer by layer process.
Right.
One component to make for example 100 number of layers. So support also initially the support their height will be less and the support height should also increase at the same time. So you will be providing the support to the structure.
I think it's just supports last minute. So these are supports. Okay,
See, all these layers are supports.
These are
See.
supports. You can change the supports also. If you not reduce the post processing time.
So initially we have made the support.
Yes,
and
yeah.
after that now it's
Yes. Now you can pause on. So this is substrate and
Substrate
these
now.
are printed. Melted. It's melting only. It's not centering. It's melting.
Like kind of fusion, you can say.
No. It's melting. There is a slight difference, but it's melting.
Actually, a lot of names will be there. DML is like.
Yeah, then always there will be a loose powder. We need to blast it, or we need to.
So this is the final part after doing post process. Without supports, you got print. This much complex, you can't able to print using normal conventional manufacturing techniques. Using AM will be particular. That to LPBF.
No, there will be two kinds of melting. One is partial melting, another one is full melting. So it will come under full melting. Partial melting is again that is centering. Sometimes we need to have binder also. We need to do debinding it and finally furnace treatment. Finally you will get 100% done. But here there won't be any furnace treatment. It is full melting technique. We are not doing any post processing in order to improve the density. It is a full melting process. But centering we need to do some furnace treatment in order to get 100% dense.
Mostly
That
it
is the
is for
difference.
polymer setting.
Even metals also, some
Like kind of binder here.
yeah, binder, they will mix with the powder, but it's a full melting process.
Apart from the heat white step,
And they can see that layering also.
you can observe one by one layering.
It's a layering is very simulation product. Layer. So layer would check. Right now it is 21 layers going on. We have totally 434 layers. Yes, see, that name, people, but we have SLS, probably you might have heard about selective laser sintering. So that was the Carl Decker patent on sintering, but it is not sintering actually, it is melting. But SLS, that is sintering, which we need to do some furnace treatment. But the name is carrying on still with the sintering, but it is not sintering, it is 100% melting. But the name, maybe the DHA, that word sintering is coming. I'm not listening.
Regarding about density of the concept, supposed to be takes around 2 kgs.
Like you take this, how much powder will you use? So I need to print this. How much powder I take? Yes. As it is, I want to print how much quantity of powder I need to.
So
Whatever it is. Yeah, steel, maybe steel. For example,
actually it depends upon the application.
this is what you tell.
It's around 10 kgs.
10 kg. 10 kg steel is not a costly, but 10 kg titanium it is very costly.
What if the titanium have mistakes, right?
Yeah, then we can even reduce the quantity of the
It
titanium.
around takes around 5 to 6 kgs. And for titanium.
Yeah, 5 to 6 kg. The titanium.
Because you have to follow like layer height, water type, volume. Next will be mass by volume, right? So if you want to get for mass, either you have one layer, next will be volume. Here volume will be suppose 100 into 100 into 8. Next will be component. Then you can get the mass, like how much quantity you have. Here you can only for example, instrument order, right? But you can't show it there. After this much, right? You can get like
Earlier I
then you have to go about the base of the point. And still depends upon the layers of
So right now we are using 434 layers. Right now it is 21 layer. 21st layer it is doing. Totally we have 434 layers. And just for the demonstration purpose, we didn't remove from the substrate. So which you can see there is supports. Now you do with the wire cut. Do you have any questions?
any queries?
So this is as built. As built, this is the surface. Finish which you are going to get. Further we can do any post processing, like sand blasting. We can do whatever post processing.
So first one you want to
ఇంకో బ్యాచ్ అయిపోయాయి, అన్ని బ్యాచెస్ అయిపోయాయి.
ఇంకా వస్తున్నారు సార్ మనకి వాళ్ళు ఉద్యోగాలకు వస్తారు ఇంకా మన బ్యాచ్ 20 వచ్చారు 20 వస్తాడు పోస్ట్
పోస్ట్ ప్రాసెసింగ్ రేట్ వెళ్తుందా మరి క్యాంప్?
సర్వీసెస్ వచ్చేసి మార్జిన్
right? After cutting from wire medium, we can get this part. Suppose let's example, and we have to do some heat treatment process. Right now we are having muffled furnace. So after keeping inside the muffled furnace, either you have to do heat treatment or aging kind of thing to increase the proper mechanical properties finally. And after that, you have to increase the surface roughness or improve the surface treatment. You have to follow the sandblasting, or you used to call it short peening. Different names will be there, but process will be the different same process. Like sandblasting, like the sand particles will spread down the surface. It will have some impact. So this much pressure it will have like in 45 bars I think so. This much pressure you can use, but depends upon the application point of view. Okay, and mostly apart from that, one machine will be the ultrasonicator. I told you initially, ultrasonicator. This ultrasonicator kind of treating only, because in order to remove the water particles it takes more time and more time. So right now we are using the only ultrasonic for especially these data structures in order to remove the powder particles like unsintered powder particles or unmelted powder particles. And for suppose like surface treatment, I told you initially like bead blasting will be another point, another application kind of thing. Okay, got my point. Apart from that, any queries?
How do you handle the titanium powder because it is prone to oxidation? So you open atmosphere and
Titanium. You are asking about titanium. Yeah. Right now we are using grade 23, medical grade. So in order to reduce the oxidation content, we have to keep in the oven only up to 80 degrees centigrade, and we have to seal it because of course it easily oxidize. So in order to remove that one, we have to give like seal.
Opening from the box itself, it can.
That much won't affect it.
Okay.
Because initially that in the machine some preheating will be there, some around 80 degrees, 90 degrees like that. So that way some content will get reduced. And initial layers we can't able to use that one. That's why I told you have to use some supports or some initial layers to to get the like present part, especially. What about apart from the any?
Told about the grade 23. You can buy it here itself in India.
No, actually in India means that orders for supplied by the systems only. Because we purchase from the systems, right? We have to use the same powder.
Raw material from the.
We can't use third party materials. If we use, we get some kind of scattering will come, defects will come mostly.
Why? Because this grade 23 is a special alloy.
Yes sir, yes sir.
Grade 5 easily you can get.
Grade 5 industrial purpose, but grade 23 for medical purpose, that too biomedical.
Underwater also.
Yeah, it is having EL I think so, extra precisions. Yeah, anything less oxygen content mostly. And I think I printed some more lattice structures using same grade 23 alloy. Right now we are in development stage of the implant design. So we hope so. Thank you. Yes, they specifically mentioned 30 microns. But they are suggesting we have to call less. More. Okay. No competition. Satellite particles. Yeah.
Go back.
So then we will sit down.
Yeah. why you want to be advanced? I've never been to AP answer this time. This is the first time I have.
When I have a complete plan about the conference,
Send me the mail.
our university people will also be happy to have a meeting with you. So, we plan for a conference as a keynote speaker. Thank you, sir. Thank you.
Thank you.
Also, don't question.
तो बाकी होता
Good afternoon, guys. Myself, Uday. I'm a scholar working under the guidance of Professor Head of the department. So right now, I'm going to discuss the demo of the metal 3D printer using LPBF technology, laser powder bed fusion. I think you might have heard about the basic principle of the laser powder bed fusion. Like, can you enlighten me? Like, what do you understand? Yeah. Yeah, of course, that is the option. Yeah. And see, first of all, there is two inside. Going to, first of all, we have to go into load the powder, right? Before going to load the powder, we have to do some pre-processing techniques. Like, first of all, now here mostly the powder particle size will be 45 microns. So, the sender will give like bigger size particles. In order to segregate, we have to do some basic thing like powder sieving. So we have to use 45 micron size powder particle, like mesh size. Thereby, only 45 microns. Above 45 micron size particles will go top. Bottom side will get the below 45 microns. Then you have to melt the powder. Sorry, you have to to remove the moisture. We have to heat up to some content. Then in order to reduce the oxidation, after heating, you have to load the powder here inside. Actually, inside two blow pods will be there. Using the help of the blow pods, you have to load the powder. So there are two main supply pistons. Means two pistons. Supply followed by center piston. In supply piston, you have to load the powder. So in this machine, we are having four materials: aluminum, titanium, stainless steel, followed by cobalt bromide. Right now, I am already loaded with 74 kg precision Arctic steel. And last in previous sessions, Srikanth might talking about the some 3D expert design, right? Thereby, you have to do some design using some process parameters like head spacing, scan quality. You might have to write. Yeah, layer thickness followed by laser power. And right now we can't change the layer thickness here. We are following same default. Why? Because they are taking the powder quantity. We have to take care about the powder particle size also. So in the medium size, we have to follow 30 microns thickness, followed by scan speed and scan strategy. Those things we can directly change in 3D expert software.
Can you do all 4 types of orders separately at a time?
No, right
and
now
then
we-
use one of them if you want?
No, we can't do that.
You can't do that.
We have to change. We have to change the powder. Yeah, change the
Order
powder.
changing is a big task.
Yeah, big task, obviously.
And you have to know how to clean it.
Yeah. And after designing the 3D expert software, you have to load the design inside the machine. And the part, like what is the powder will spread accordingly, like whatever, like what say layer thickness I told you, 70, 30 microns. So initially you have to use 70 microns. Right? Because after spreading slowly, the thickness will go into change. Because there will be some bridge will be there, bridge scale. Bridge. Followed by center piston. So the bridge will occupy some space. So ultimately you used to get some 30 to 40 microns. Finally. Then the laser will go into melt the powder. And next layer will spread, laser going to melt. Same thing will happen, but stacking of 2D layers. You will get third 3D component, right? Same thing happened here. And so this is the basic user interface of the machine. You can observe. So total around 434 layers will be there. Right now it's falling on 131 layers. So you can observe this is the like a display. So these 4 are tensile samples, and these are the cylindrical samples we using lattice structures. Okay, and it will show you the how much estimated powder height. So it depends upon the different powder particles. How you calculate different same concept like density equal to mass by volume, right? You have to calculate the mass and you have to multiply with density. Different materials means titanium different density, steel different density like that. Volume will be 100 into 100 into ATM height. Same thing we have to follow. So based on the calculations, you can get this much height, so this much quantity is required. You have to load the powder like that. Right now we loaded around I think 2 kg, I think so. Why? Because initially some sintering will come. Before going that you have to do some remelting. Why? Because they are using substrate, right? Inlay, and it should be attached to the part. So in order to some time it is going to detach or it war will come. In order to remove that problem, we are doing remelting, means double times. Then some part will get to attach to the surface. So those part we can easily remove wire cut detail. So that is not required. That's why we are following 10 layers mostly.
What is the minimum quantity of powder you should use? Minimum.
Yes, sir.
Minimum quantity. How much quantity of powder?
Powder. It's initially yes, we asked.
Minimum. For example, you don't have that much of quantity of powder
Yes, sir.
for a material.
Actually, it depends upon the particle height, sir. Suppose they are having particle height of 1
No,
centimeter.
say particle size 50 to 44 microns.
It will depend upon the part.
What's the minimum? Then put it.
I got it.
I said because I bought a 20 kg of powder or 10 kg of powder. Can you use it? 5 kg of powder.
Actually, basic idea is first of all you have to design the right part, right?
No, not part. It's only some small sample.
How much height? How much height?
Small mini sample will
I'm asking height in centimeters.
maybe 5 mm.
5 mm.
10
Yeah.
by 5 mm.
Yeah.
But what is the minimum quantity of powder that you should use?
Actually, regarding about the calculations like mass into density into volume. Suppose titanium.
He is
No,
asking
what is the
whether
minimum
you
size of the
like
part?
you have the dispenser part.
Ah.
On that dispenser, do you see any residual particle that won't be able to hold up? Even like this question, like my previous question, the dispenser is below that level, so we need to have extra water in that. Like dispenser is at the same level as of the filter, so the powder.
Okay, asking yes, sir. No, Actually,
Like in this machine there is no extra
no
power.
extra power, sir. We have to level the
Like in this case, build platform and recorder, that dispenser is at the same level.
same level.
Generally for PGF, generally you need large quantities of water. You
not
don't
that
want to
much.
print small samples.
Not that much, sir. Compared to like other products, DED kind of thing, we do not require that much.
DED is much better. I can put 1.5 kg of powder.
Yeah, DED, like how can you say, like, can't you print?
See, in the
It
hopper,
will,
the DED in the hopper.
it will depend upon the build platform size. If you are having a build platform
That's what I'm asking.
10 by 10, na, you need to fill
Here,
it 10 by
100 into
10.
100 into 8 kg. Means 10 centimeter, 10 centimeter, 8 centimeters.
So that is the minimum quantity of
Yeah.
powder.
That's a base build volume. Okay, you're asking about build volume.
No, I'm asking minimum
Lower
quantity
quantity
of
of
powder.
powder.
No
For
quantity.
example, I say that I have only 5 kg of powder.
Okay.
I want to pick very, very small samples, which
Yeah.
consume probably
Like
half
half
kg of
kg,
powder.
half
Half
kg.
kg of powder. Can you do it? Can you do it?
Depends upon the material also. Material
Sir,
sensitive.
again, you-
Okay, take it again, sir.
Okay.
I'm just throwing it
Half
out.
kg it is.
I just want to get an idea how much minimum quantity of powder that you need to start printing.
That will again depend the mass of the powder
Yeah.
that you have. That will be equal to the total of mass of or volume of the powder it
How
can
much
cover.
volume you need? Okay, in other words.
100 into 100 into
So,
80.
sir, as you are
That's the minimum quantity you need.
Depending on the pencil.
so I am saying like just maybe like you are having part of 2 mm, but the build platform is of 10 by 10 and it can go up to maximum 80 as 80.
Yeah, max 80.
So
you have to
if
figure
your
out
part,
20.
even though if your part is of 2 mm,
Ah.
but it needs to fill that 10 by 10 volume.
10 by 10 by
2. 2.
2
Now I got it. Okay. So compared to DED, it will have less.
You need much less powder. Much less.
But their vessel is lot when compared to that.
Very big, yeah.
But here we can't able to print this kind of complex like
It won't be able to possible in
Yeah.
DED.
No. I'm not going to argue that.
Okay.
I know what the
No, with the combined turning to do the last layer spreading uniformly, that is a big task. You need the extra powder also.
That's what I'm
That's,
asking.
it will
Yeah.
it will
And
depend
again-
upon the recorder speed only.
And again you have to use also. There will be one ratio will be there. 1 by 3 ratio.
Complete bread with the spread అవ్వాలి కదా. The excess powder ఉండాలి.
Okay, this is the final part like after doing post processing means wire continuum. In the meanwhile you can show like 1 by 1 you can show
How much time it will take to print this?
only one sample like height.
For example, this side.
7 to 8 hours. 7 to 8 hours time. Titan yeah, sir.
So, initial is
That one, this one. This one 738 inches, 735 layers.
what is the material?
Titan. But here mostly used for complex structures, sir. And of course in the end small build volume only. There are different machines will be there like
But because you are working with powders which are like
yes sir.
large quantities of powder, like several only 10 kg for 5 kg. Can you handle it? That's the question. Only 5 kg of powder.
Cell powder.
Because its build platform size is lower.
Then what's right here? Yeah, volume. Volume and density of the somewhat like it can.
That's extra, I don't know.
Okay. Yeah, rough estimation only how to say that actually. So we try up to 1500. But you can go for 2000 also. Yeah. So what that's why I tried maximum 500 prices something. And again we are getting 90 watts. This is fine. Yeah. So you heard about that experiments like scans. Post processing with us. Not just the that's 100 watts. What I mean. What I mean. 75.
మార్చండి దగ్గర పెట్టండి అది పెడతాను
Get some parts which are not moving because it is attached to the surface. Thereby, you have to do some kind of sandblasting or heat treatment. Yeah, right now we don't have that facility, sir. That is also best one. Still, some particles are attached to the surface. We are facing that issue like mechanical post passing. And right now, one of my post colleagues also working on post passing to especially to remove the additive particles. Yeah, partially with it.
I know.
Okay.
See, we have this is forward unit manufacturing. Also, we are calling selective laser melting process. Here we are using laser and powder will be distributed on the bed. And our machine is having a build size of 100 by 100 mm. In all the X, Y and Z direction, 100 mm size we have. And we will distribute the layer of powders, and with our laser system we are going to bend whatever according to our geometry we are using. That geometry is created by our 3D export software. Right? In that we are defining how many number of layers, how printing has to be taken place, and what type of scan strategy, how much laser power we have to feed. Okay, if you see this window, you can able to see once we have loaded the powder into the system, we will be having two hoppers, one left hopper and right hopper. The left hopper we are feeding the powders, whatever may be the materials, aluminum, stainless steel, titanium, copper, chromium, whatever material we can feed it, then it will store and distribute over the build platform here using the roller or by the dot display. With this system we are having a roller, it will distribute the build platform area and excess powder will come into another hopper. Okay, and then we are feeding whatever the programming, we have to purge that argon gas to completely into the chamber. And we need to maintain the ppm level not to oxidize our pore part, melting. That's why we have to maintain the O2 level. If you see here, 3 ppm level. Okay. If it goes more than 1000 ppm, machine the argon will purge back. Like that, your system is attached with the argon gas. Complete chamber is argon. Like that, purging will be taking place to maintain the chamber. And then once the laser is sintered the first layer, then the second layer of powder particles will distribute on the build platform area. Like that, the second layer is also melted or sintered with powder particles. Like that, process is going on, repeating, and then that much layer height will keep on going down. Your build platform is going down in every layer, and every layer of powder is going to distribute. Okay, if you see that process how it works, every layer it will center, and then the second layer of powder particles will come, then again it will center. All this path planning we have to do with our 3D export software. But for other systems we use Ultimaker or the other different kind of software. But for this system we are using PDF system, 3D export, because for the color machine we are using the printer. If you see one by one you can see those. You can do miniature sample, whatever sample. See, we have a built part of area. Today, we need to design our part. Accordingly, you can build whatever sample you want. But now we are building some kind of body structures for compression, and some parts are for tension testing. The tension testing is 50 mm belt, and arc thickness of 3 mm. That we have defined based on the PST V8 standard. Based on that we can able to print and we can able to test. But whatever printing is taking place now only are in the manner. We are qualifying method only in analytical. In vertical means again we need to put that much amount of powder particles. Now you will see here, it takes almost 5 hours to print entire part. The total number of layers is 187 layers. Till now it is 187 layers it is printed. Okay. The part height was 5.6 mm, 13 mm, but till now it is printed only 5.6 mm. Till again another 8 hours is left. So machine will 24 hours, even 48 hours, 3 days, 4 days, continuously running. We need to check the argon and the command should be able to okay. You can see the O2 level. If O2 level comes up, again we need to see to the cigarette empty or what. We need to check the cigarette. It's a keep on continuous process. But earlier it was not selective laser printing. Now we are laser powder bed generating method. And we have some of the post-processing equipment, like we can, after printing, we need to extract. We saw that YDM machine was used. This is used for removing the printed part from our print platform. Or we can use AXA, or we can do sandblasting, or we can do heat treatment, or other static casting, heating, and all these things we can do after printing. Okay? Once it is printed, we are cooling down in the system itself. During that time, we are not taking any argon, but no other system is there in the world. Because argon is there in the system, but no argon can be collected after printing also, right? No argon collected because argon is disposed to environment. But there is no system. That is one people can become sustainability to store argon. Use the argon also they can store, they can purify again, they can make it useful, reuse it. But whatever if you see, only tensile area is printing, only this area. See, this is the area you are printing. Remaining all other area powder particles will be there. That is not printing. But that powders again we use and receive it with a vibrator receiver. We have different receiving machines. With that we remove agglomerated powder particles and then whatever the fresh powders again we reheat it, very contamination of moisture and all. Then we put as the powder into the machine with original powder with the ratio of 60 to 40%. You see surrounded by this area, powders are already like stiff or spattered. You see some spattering is coming. The spattering means well melting some powder particles ejecting from the melt pool. That is shifting onto another area. That will not be used because that is already absorbed by the heat. That we cannot able to use. If that used, again you are end up with the defects. You cannot able to melt properly. Oxidation problems and all. That's why we need to use only the surrounded powders which are not melted and again receive, reheat and then we can use it. That is the purpose we can use it. Okay. You can go to that FDM system. If you want to see some of the post-processing equipment we have here,
Hello, madam.
చెప్తారు.
Okay. What is LPBF? LPBF. Apart from some technologies, this is one technology, right? LPBF. Laser?
Powder bed.
Powder bed fusion. So what is the basic principle? I think practically already might taught you about the sound technologies. Or selective laser melting also you can say that part. What's the basic principle here? Just think. Okay?
The powders are made, fire maybe made.
Fine.
Maximum.
Okay.
This part.
Okay. So mostly, first of all, the powder will spread that substrate, right? With the help of the laser, it will go into full melt. Next, after next layer will come. Means stacking of 2D layers. Finally, you get the 3D part. So, okay? This is a basic principle. So, this is a 3D system machine. DMP flex container. Direct metal printer. Flexible. 100. 100 means build volume. 100 to 100 into ATM height. So, ATM. So, laser power will be around 100 watts. So, here in this machine we can use 4 materials, different materials. Titanium, aluminum, stainless steel, followed by cobalt material. Okay. Before going to load the powder, first of all you have to do some pre-processing techniques. What is that means? Like powder. Powder is having 45 micron particle size. So in order to maintain, you have to do some sieving because suppliers will use some random particles. So in order to segregate, we have to use some sieving technique. Yeah, sieving. Then after sieving, we have to keep the oven, keep it in oven. Why? Because to remove the oxidation, like moisture. Yeah. Then after load the powder, using glow pots. Instead glow pots are there. With the help of the glow pots, you have to load the powder in supply mixture. And followed by you have to give some fabrication pipe, we used to call it. Like I think they might thought about 3D expert, right? 3D expert software. 3D expert software. Okay. In 3D expert software, you have to do some design. Then after doing
Yesterday, Srikanth have told you like entomology, right?
Yeah.
The lattice or
Entomology.
for example, anything.
Yeah.
That you need to design first. Using SolidWorks or anything.
Mostly coordinate like entomology for 3D
axis, how much distance, thickness.
Yeah. But here it is the 3D expert software is related with this 3D system. For this mission only it will work. When it comes to some LED process, they will use some master cam. It depends on again the mission. The supplier will give you the respective system, like a software that you need to work on it. That related with the machining.
whatever the process parameters, everything you can give in that software.
After giving the process parameters, then the machine will use the what I say galvanometer for lasers and the pneumatics for to move the supply piston up and down. First of all, the roller will spread the powder on the substrate. Then the laser will go into build the powder particles. It will spread one layer, next layer, stacking of two layers, same principle. Whatever you applied in APM, same you can get in here also. Stacking of two layers, 2D. Finally you can get 3D component. So here there are four five parameters for energy density. Have you heard about energy density? This one, energy density. Yeah, for process. Means this much of energy required to melt the powder at certain region, right? So it depends upon the laser power, followed by scan speed, layer thickness, hash spacing. Okay, this four parameters. Here you can't change the layer thickness because 30 microns is the fixed here. So we can't change. And another part you can change laser power, you can change hash spacing. Yeah. Hash spacing in the sense the laser will be going to enter the powder, right? On the specified region. You have to give some spacing of the two regions. Here you can observe do one thing one by one can observe here. I can tell you what do you understand. Yeah, first see the process, then I will show you the part. One by one.
You can see the filtering.
Once you're done,
Not explain live
Okay, see this is the final part. 3D component. Okay, after we have to do post processing. What are the post processing techniques? First of all, I need to remove the component from the substrate. What is that? EDM. Why do you get EDM? Fine. Next, apart from that,
Extra
yeah. What is the process what is the technique? Sand batching is fine. Because some particles are unmeasured particles will go inside, right? For this lattice especially. How do you remove? Have you heard about ultrasonicator? Ultrasonicator, which is used to vibrate the sample. Okay, that's what we can use. Of course, sandblasting also you can use, but for these intricate shapes, you can't use the sandblasting because the flow don't go inside directly because it is having curvature kind of thing. Okay, that's a problem. So better to use ultrasonicator. So that is also one of the post processing technique. And apart from that, okay, fine. Next. Yeah, surface grinding also you can do. heat treatment. Okay, but in our lab we are having sandblasting followed by buffer furnace. Okay. In between we can show inside.
Once it was printed, we will remove it from the build. Then the printed samples will look the same. Like whatever what you are going to give the structure, that will be depends. Here, if you can see, it was more than 45 degrees. This lattice, if you can see. So they have given the some support here. You can, if you can visually see it, there is some solid support, right? That will be in order to having some overhang structures. So once after this, we will be cutting with remove the samples from this build plate using a iridium. I hope you guys heard about it, right? There will be some wire which is of a thickness 0.18 mm. So it will through the conductivity, it will remove the parts from our build plate. Best possibility to remove the build plate samples from the build plate is of iridium for additive samples, I can say, because we are very much depend about the material and everything. We don't want to get wasted. So it will be having very minute thickness which is of 0.18. So it will be considered as a negligible. In that case, we will remove it. Then for normal samples, solid samples, in LPBF you can say that mostly the near net shapeable components will get obtained. But there will be still we need some more surface, like a more smooth surface. Here you can see some roughness which will be having on your, if you can touch it, you can get to know. There will be some higher surface roughness. In that case, there will be some post-processing techniques. You can say short peening or sandblasting and those things. That will help you to reduce the surface roughness. Here we can see this is a sandblasting. It was not on. This is here you can see, right? Just normally we will remove it. Yeah. It is also just like a glow box which you have seen it in LPBF. The sample will be kept inside, and you have to hold it with using glow box only. Because you can see there will be some sand blast. You can see, right, very small particles that will be coming with some high pressure, and it will hit the surface and remove the whatever the higher component are. It will make you the surface to be smoother. So if you just, there will be large reduction in the surface roughness using this sandblasting technique. And also there will be some other process, short peening and everything, that you can, it will be helpful for you to reduce the surface roughness. So, and other some post-processing techniques what you can adopt is like in the lattice structures, if you can see, here it is having a more pore size. It will be less, like a more than 3 mm, 4 mm. Here you can visualize it, we can see everything through the hole. But there will be some lattice structures